Okay, let's try another example. And this one is in 2 dimensions. So we have the figure to the right. In the figure to the right, a plane moves due east while the pilot points the plane somewhat south of east toward a steady wind that blows to the northeast. The plane has a velocity VPW, so the velocity of the plane relative to the wind, with an airspeed relative to the wind of 215 kilometers per hour, directed at an angle theta south of east. The wind has a velocity of the wind relative to the ground with a speed of 65 kilometers per hour, directed 20 degrees east of north. What is the magnitude of the velocity of the plane relative to the ground, and what is theta? Woo! Okay. So first and foremost, because this is in 2 dimensions, we have to split it up into x and y components, just like we've done with 2-dimensional problems before. So let's just do that with the velocity of the plane relative to the wind and the velocity of the wind relative to the ground. So velocity of the plane relative to the wind looks something like this. We don't know this theta, okay? But we do know that the velocity of the plane relative to the wind is 215 kilometers per hour. And this is velocity of the plane relative to the wind. Okay. Now we also know that the velocity of the wind relative to the ground is up like this. We have this angle right here. That will be our x component. And this is 65 kilometers per hour. This is velocity of the wind relative to the ground. And then our angle right here is 20 degrees. I'm going to write that in. Now, this will be velocity of the wind relative to the ground, x component, velocity of the wind relative to the ground, y component. This will be velocity of the plane relative to the wind, x component, and the velocity of the plane relative to the wind, y component. So down like that. Okay. So we want to know, what is the magnitude of the velocity of the plane relative to the ground, and what is theta? So first and foremost, do you see how our velocity of the plane relative to the ground only has an x component? So since it only has an x component, that means that our y components have to cancel out, right? So what that tells us is that velocity of the plane relative to the wind in the y direction plus the velocity of the wind relative to the ground in the y direction has to equal 0. So that means the velocity of the plane relative to the wind in the y direction equals a negative velocity of the wind relative to the ground in the y direction. And I know I can solve for a velocity of the wind relative to the ground in the y direction because I know the velocity of the wind relative to the ground and I know the angle. So since that is adjacent to that angle right here, I'm going to use the cosine. So cosine of 20 equals adjacent velocity of the wind relative to the ground in the y direction divided by that 65. So we get for velocity of the wind relative to the ground in the y direction is equal to 65 times the cosine of the angle, cosine of 20. And we get 61.1 kilometers per hour. So that tells us that the velocity of the plane relative to the wind in the y direction is equal to a negative 61.1 kilometers per hour. So now, and remember that negative is just negative because it's directed downward. So now that I have that component, my y component of the velocity of the plane relative to the wind in the y direction, and I have the hypotenuse, the velocity of the plane relative to the wind, I can find that angle that I'm looking for because I can use the sine. So sine of the angle is equal to opposite, which is the velocity of the plane relative to the wind in the y direction, so 61.1 kilometers per hour, over hypotenuse, which is 215 kilometers per hour. So I take the inverse sine of that, 61.1 divided by 215. and I get 16.51 degrees. So there's my angle. And then now that I have the angle, I can then find this velocity of the plane relative to the wind in the x direction. So velocity of the plane relative to the wind in the x direction will be 215, so the velocity of the plane relative to the wind, times the cosine of that angle that I just found. So 215 times the cosine of 61, sorry, not 61, 16.51. So cosine of that answer, and then times 215, we get velocity of the plane relative to the wind in the x direction is equal to 206.135, so about 0.14 kilometers per hour. So now that I have both of my x components, I can then just add them together and find the velocity of the plane relative to the ground. Because again, I know that there's only x components in this velocity of the plane relative to the ground. So I'm going to add them together. I have the velocity of the plane relative to the ground will be equal to the velocity of the plane relative to the wind in the x direction, x component, plus the velocity of the wind relative to the ground in the x direction. So here we get velocity of the plane relative to the wind in the x direction was 206.14 kilometers per hour, plus velocity of the wind relative to the ground in the x direction, which we haven't found yet, but we can find with our angle right here. So it's going to be the sine of the angle is velocity of the wind relative to the ground in the x direction over 65. So that will be 65 times the sine of that angle, which was 20 degrees, right? Yeah. So here we end up getting 206.14 plus 65 times the sine of 20, which is 228.37 kilometers per hour. Now we only found the x direction because that plane is only going in the x direction. We can see that from the picture. However, if there was also a y direction and those didn't cancel out like they did, then we would just have to find the x direction and the y direction and then use Pythagorean theorem to add them together. Now, one more note here. When we have, remember, we have our subscripts here, a subscript on the inside, if that matches the first subscript on the second term, so second subscript on the first term matches the first subscript on the second term, then those cancel out and you end up getting the velocity of the plane relative to the ground, which is what we wanted right here. So that also follows that rule that we talked about in the video before.